Good afternoon, students. Today I will going to explain the concept of rolling of a body from an inclined plane. Okay. Suppose consider an inclined plane here. ऐसा. Suppose consider an inclined plane. This is an inclined plane. It's an inclined plane of inclination theta, right? It has an inclination theta. Consider a body of mass m है बेटा. Suppose consider a body of mass m and radius r is allowed to rolling on a down inclined plane like this, which is allowed to rolling on a down inclined plane like this. Here initial velocity of the body I have considered 0. From initial velocity 0 to it is allowed to rolling on a inclined plane. Okay. Then what is with what acceleration it could be reach the bottom of an inclined plane, and how much frictional force will acting on a object, and how much amount of the time it will be take to reach the bottom, and with what velocity it would be reach the bottom. Those all quantities now I should have to discuss. Okay. Here see, suppose the body is rolling here like this. When it is at this point P, its weight will act downward direction. No? Its weight is acts downward direction like this mg. Okay. And the normal reaction force will act like this upward direction n. Okay. And when the body is rolling, what condition is applicable here? So angle of inclination and angle of friction both will be equal here. Angle of inclination and angle of inclination and angle of friction both will be equal. That means angle of friction is equal to angle of repose. Both will be equal there. Okay. This mg can be resolved into two rectangular components. First one is in the direction of angle, mg cos theta. Okay. Next, other than direction of angle, mg sin theta. Okay. So what about the okay? Next, the friction force at the point of contact would be acting backward direction like this. This is a Fr. And the object is rolling, what is that? With an angular acceleration alpha, let's say. The body is rolling with an angular acceleration alpha. Okay. So the moment of inertia about this point of contact is given by, what is the moment of inertia about this point of contact? The moment of inertia about this point of contact is given by I is equal to ICM plus mr square is already knows. I is equal to ICM plus mr square about this point of contact. Therefore, about this point of contact, the torque acting on the object about this point of contact is given by, what is the torque? The torque about this point, let's say this point is a P low. P is equal to mg sin theta, force is a mg sin theta, okay, into perpendicular distance about this point of contact would be nothing but r. R is a radius of the sphere, that is equal to r, into r is equal to I alpha is already know. Torque W is equal to I alpha. So this is what I am writing. See, mg sin theta into r is equal to, what is the moment of inertia about this point of contact? ICM plus mr square. ICM means what is ICM? mr square plus mk square. mr square plus m square, alpha value is a upon r, already you know. I did explain detailed about the relation between alpha a and r. Okay. So from this equation I have to calculate acceleration. So what is the acceleration? Both sides m will be gets cancelled out here. Okay. And this r take this side, g sin theta into r square is equal to r square plus k square into a. A means what is a? the center of mass is moving like this. The center of mass is moving with downward direction, that is ACM, with an acceleration ACM. Let's take this ACM. This also I am writing ACM. Okay. The ACM would be is equal to, what is ACM? ACM is equal to G sin theta into R square upon R square plus K square. R square upon K square. This is what I am writing. See, ACM is equal to G sin theta upon, this R is taken in the denominator. How would be this equation change? See, R square plus K square upon R square. R square plus K square upon R square. This is what I am writing in the form of C here. Therefore, the acceleration of the center of mass is given by ACM is equal to, what is ACM? ACM is equal to G sin theta upon 1 plus K square upon R square. This is the acceleration of center of mass of this body. The acceleration of center of mass of the body is given by ASM is equal to G sin theta upon 1 plus K square upon R square. Okay, so this is the applicable, this acceleration is applicable only for linear motion only. For rotational motion, the torque due to frictional force, the torque due to friction, the torque due to friction is given by, about this point of contact, what is the torque due to friction? F cross R is equal to I dash into alpha. That is, what is I dash value? I dash is equal to mr square. Alpha value is nothing but A upon R. Okay. So from this, the friction force is given by F is equal to mr square into A upon R square का बराबर है. वो R square will get cancelled out. Therefore, F is equal to MA. MA means what is A? A means ACM hai beta. A means what is that? ACM, acceleration of center of mass. But the body is moving with an acceleration of ACM is equal to G sin theta upon 1 plus K square plus K square upon R square is already know. That value substitute here. That is F is equal to M into, what is ACM? G sin theta upon 1 plus K square upon R square. So this much frictional force would be acting on the object when it is rolling downward direction from this inclined plane. Is it clear? Suppose if the coefficient of the friction between the contact surfaces would be is equal to mu low. Let's take the coefficient of the friction between the contact surface is mu. Then the coefficient of the friction is given by, what is the coefficient of friction? See, the coefficient of friction is given by mu is equal to F upon N, because of the friction force is always direct proportional to normal reaction force. From this, the friction force is equal to some coefficient into normal reaction force. So from that, the coefficient of friction is given by mu is equal to F upon N. But what is the value of F? Mu is equal to, F value is a mg sin theta upon 1 plus K square upon R square is whole divided by mg cos theta. So the normal reaction force, which is balances with, what is that? Mg cos theta. The normal reaction force would be balances with mg cos theta. Is it clear? Therefore, that's what I have written. Mu is called mg sin theta upon 1 plus K square upon R square upon mg sin theta. Therefore, mu is equal to, where mg gets cancelled out, sin theta by cos theta would be the tan theta upon 1 plus K square upon R square. So this much coefficient of the friction would be arises between the contact surfaces. How much amount of the coefficient of the friction would be arises? Mu is equal to tan theta upon 1 plus K square upon R square. This much amount of the coefficient of the friction would be arises, okay, while rotating the object. Suppose for pure rolling, what conditions are applicable? Suppose if the body is rolling purely, that means it could not be slipping and it could not be sliding, okay, it could not be jumping and giving any amount, any type of the jerks, and it is rolling purely applicable. So the conditions for the pure rolling is condition for pure rolling condition for pure rolling is, what condition is applicable for the pure rolling here? See, so the frictional force must be less than or is equal to mu into n. Condition for in case of horizontal rolling, what condition is applicable for the pure rolling? VCM is equal to R omega, okay. In case of horizontal plane, what happening is there? In case of horizontal plane, what happening is there? For the pure rolling, okay, V is equal to R omega will acting like this direction and VCM is acting along the direction. So what condition is applicable for the pure rolling on the horizontal plane? VCM minus R omega is equal to, what is that? VCM minus R omega is equal to VCM minus R omega is equal to, what is that? 0. VCM minus R omega is equal to 0. So from this VCM is equal to R omega. So this condition is applicable for the pure rolling on the horizontal plane. Whereas in case of when object is rolling on an inclined plane, so condition is applicable for the pure rolling is the frictional forces must be less than or is equal to mu into n. So what is the frictional force? Frictional force also already you know. What is the frictional force? mg sin theta upon 1 plus k square upon r square is less than or equal to mu into mg cos theta. Is it clear? So from this what I am writing, the value of mu would be is equal to mg on both sides, mg will get cancelled out, sin theta upon cos theta 1 upon 1 plus k square upon r square into sin theta upon cos theta is less than or is equal to mu. Is it clear? Sin theta upon cos theta means tan theta, no? Therefore, tan theta upon 1 plus k square upon r square, which is less than or is equal to mu. Okay? This condition is applicable for the pure rolling. For the minimum value of mu, for minimum value of mu, what I am writing, see here. For minimum value of mu, what I am writing, see, mu minimum is equal to, what is the value of mu minimum? Tell me. What is the value of mu minimum? Tan theta upon, that is equal to tan theta upon 1 plus k square upon r square. So this condition is applicable for the minimum value for the pure rolling. For the pure rolling, the quotient of the friction must be this much beta, okay. And this condition is applicable for the pure rolling. Is it clear? Is it clear or not? Respond. Is it clear now? Okay. Next, see, based on this concept, see some problems. Suppose consider an inclined plane beta. Suppose consider an inclined plane. This is an inclined plane. This is an inclined plane of inclination theta. Okay, inclination theta. A object is rolling. A object is rolling like this. A object is rolling from top to bottom in downward direction. Okay, from top to bottom in downward direction. Let's say this is a x-axis and this is a y-axis. So with what velocity it could be reach the bottom? V is equal to how much? And how much amount of the time it will be takes? how much amount of the time it will be takes to reach the bottom. Okay. Here see, when the object is rolling on down the inclined plane, how many forces will act on this? Friction force is acting upward direction, F, and one more thing is a friction force is acting downward direction. So mg sin theta will act downward direction. So what is that? Weight will act downward direction is better. Mg sin theta is acting along the parallel to the plane, and mg is acting, what is that? Downward direction, and normal reaction force will act upward direction like this. Okay, making some angle theta, same angle theta, whereas with what angle we have inclined the inclined plane. Mg can be resolved into two rectangular components. First one is a mg cos theta, and second one is a mg sin theta. So with what linear acceleration is coming to downward direction? A is equal to g sin theta upon 1 plus k square upon r square, with this linear acceleration which is coming to downward direction. Okay. So with what velocity it would be reach the bottom? With what velocity it would be reach the bottom? Whatever the initial velocity here, initial velocity u is equal to 0 is already known, because of initially the object is starts rolling from rest only. That means its initial velocity would be 0. Therefore, the velocity with which reach the bottom of the plane is given by here. When the body is reached, whatever its velocity v is equal to how much, that is now we have to calculate. So applying the second equation of motion, what is that? V square minus u square is equal to v square minus u square is equal to 2as. But what is the length of the plane? Length of the plane we don't know. Let's take the length of the plane would be L. The length of the plane would be, the length of the plane would be is equal to LA, that is LA beta. V square minus u square is equal to as. That means v square minus 0 square is equal to 2 into a value is g sin theta upon 1 plus k square upon r square हो जाता बेटा into L. Okay, into L. So from this v square is equal to, what is the value of v square? Is equal to 2gl into sin theta upon 1 plus k square upon r square. So with this velocity, the body would be reach the bottom. Okay, with this velocity the body would be reach the bottom, would be equal, that is that 2gl into root over sin theta upon 1 plus k square upon r square. Okay, how much time it will be takes? The time taken by the body to reach from top to bottom is given by the time taken by the body, the time taken by the body to reach from top to bottom is given by how much time it will be takes. The time taken by the body to reach from top to bottom is given by, what is that? S is equal to ut plus half at square apply करो. S is equal to, that means L is equal to ut plus of ACM into t square. But u value, initial velocity would be 0 there. Therefore t square is equal to, what is the t square? T square is equal to root over 2l upon ACM हो जाते हैं. But what is the value of ACM? The object is moving with an acceleration of center of mass ACM is equal to g sin theta upon 1 plus k square upon r square is already know. वो value इसमें substitute करो. T is, this is a t only, not t square. Already we have put the square that side. Therefore t is equal root over 2l upon ACM हो जाता है बेटा. That is t is equal to root over 2l upon, what is the value of ACM? ACM value is a g sin theta है बेटा. That is a g sin theta upon 1 प्लस के स्क्वायर अपॉन आर स्क्वायर का बराबर है। दैट इज टी इक्वल क्या आ जाता है बोलो, रूट ओवर 2l इंटू 1 प्लस के स्क्वायर अपॉन आर स्क्वायर divided by g sin theta. This much time it will be take to reach the bottom. Is it clear? The time taken by the body to reach the bottom is given by t is equal to root over 2l into 1 plus k square upon r square by g sin theta. Is it clear or not? Is it clear? So how many points are there in this? First of all, we have calculated what is that the acceleration of the center of mass in this case is given by ACM is equal to g sin theta upon 1 plus k square upon r square hai beta, and frictional force would be equal to mg sin theta upon 1 plus k square upon r square. The next one is the minimum, what is that, the coefficient of the friction minimum required for the pure rolling is equal to this much. Okay, is it clear? Next, the velocity with which reach the bottom is given by v is equal to square root of 2gl sin theta upon 1 plus k square upon r square. Next, the time taken by the body to reach the bottom is given by t is equal to square root of 2l into 1 plus k square upon r square by g. Okay, so these conditions are applicable when a body is rolling down inclined plane. Is it clear? Okay, next see, based on this concept, see some problems, J problems देखो इधर. Suppose consider an inclined plane है बेटा, वो भी inclined plane ऐसे है. This is a inclined plane. Consider an inclined plane. This is an inclined plane. Consider an inclined plane. Inclined plane ऐसे ले. This is an inclined plane. Of inclination कितना बेटा? Inclination is theta दिए. Inclination theta. Okay. Which has a height h. Okay. A solid cylinder has a mass m and radius is rolls down on a inclined plane like this. Is a solid cylinder. What cylinder? Solid cylinder. This is a solid cylinder. Solid cylinder. Solid cylinder. It has a mass m and a radius r, is rolling downward direction like this. Is rolling downward direction like this. Is rolling downward direction beta. Is rolling downward direction like this from the top of the inclined plane to downward direction is rolling. Then find the velocity of the center of mass when it would be reach the bottom. When it would be reach the bottom, find the velocity of the center of mass. V same is equal to कितने, and how much time it will be take to reach the bottom. Here take the, let's take the length of the plane would be is equal to LO. Is it clear? This is solid cylinder beta. Solid cylinder, it has a mass m and radius r, which is rolling down on an inclined plane of inclination of theta beta. Okay, how much time it will be take to reach the bottom, and with what velocity it would be reach the bottom of the plane. That those two quantities now we should have to calculate. Okay, when it is coming to downward direction, what is the acceleration? With what acceleration it is coming? ACM है बेटा. What is ACM? ACM is equal to g sin theta upon 1 plus k square upon r square is already known. The acceleration of the body, in general condition, the acceleration of the body is given by ACM is equal to, what is ACM? ACM is equal to g sin theta upon 1 plus k square upon r square. बट इसमें क्या दिया है, वो सॉलिड सिलेंडर दिए है. दिस इज सॉलिड सिलेंडर है. सॉलिड सिलेंडर मीन्स व्हाट इज द मोमेंट ऑफ इनर्शिया ऑफ द सॉलिड सिलेंडर अबाउट दिस एक्सिस ऑफ रोटेशन वी डोंट नो, दैट इज वी हाउ टू कैलकुलेट. सो द मोमेंट ऑफ इनर्शिया ऑफ द सॉलिड सिलेंडर इज ऑलरेडी नो, आई इज इक्वल टू mr square by 2 है बेटा, लुकिंग लाइक ए डिस्क है, दैट इज इक्वल टू विच इज इक्वल टू mk square. On both sides what would be gets cancelled out, mm gets cancelled out. From this k square upon r square is equal to k square अपॉन आर स्क्वायर इज इक्वल टू 1/2 आ गया, ठीक है। देयरफॉर द एक्सेलरेशन ऑफ द सेंटर ऑफ मास इज गिवन बाय ए सेम इज इक्वल टू कितने बेटा, ए सेम इज इक्वल टू जी साइन थीटा अपॉन 1 + 1/2 हो गया। दिस इज इक्वल टू ए सेम इज इक्वल क्या हो गया बोलो, ए सेम इज इक्वल टू 2g sin थीटा 2g sin थीटा अपॉन 3 हो गया। So with this acceleration it would be coming to downward direction, okay. So the velocity with which reach the bottom is given by what is that, v square minus u square is equal to 2as है ना, v square minus 0 square is equal to 2as, what is the 2as, 2 into v square minus u square is equal to 2as से बेटा, v square minus u square is equal to 2 into acm into L है, that was L, okay, L was given, this length was given L है बेटा, therefore v square is equal to, or v is equal to, directly I am writing here, see what is the value of v, v is equal to what is the v is equal to square root of 2 acm into L हो जाते हैं, ठीक है। So what is the value of acm, acm value is equal to 2g sin theta upon 3 is already known, this value substitute here, v is equal to square root of 2 into 2g sin theta upon 3 int L हो गया बेटा, ठीक है। दैट इज v इज इक्वल टू स्क्वायर रूट ऑफ 4gl sin थीटा अपॉन 3 हो गया। विथ दिस वेलोसिटी इट कुड बी रीच द बॉटम, बट फ्रॉम दिस ट्रायंगल इट इज वेरी, फ्रॉम दिस ट्रायंगल यू कैन टेक साइन फंक्शन, साइन थीटा इज क्या मिल जाते, साइन थीटा इज इक्वल टू h अपॉन l मिल जाते ना, h अपॉन l, इसमें सब्स्टिट्यूट करो, देयरफॉर v इज इक्वल टू स्क्वायर रूट ऑफ 4gl इंटू h अपॉन l बाई 3 हो गए, एल गेट्स कैंसल आउट हो गया बेटा, v इक्वल क्या हो गया बोलो, स्क्वायर रूट ऑफ 4g h upon 3. So with this velocity it would be reach the bottom. Therefore the velocity of the particle at the, when it is reach the bottom is v is equal to square root of 4g h upon t. Is it clear? Is it clear not? Is it clear or not? बोलो, बहुत आसान है ना प्रॉब्लम। नेक्स्ट, how much time it will be take to reach the bottom? Next we have to calculate the time taken by the body to reach the bottom. How much time it will be take to reach the bottom? See, how much time it will be take? How much time it will be take to reach the bottom? Generally distance is equal to velocity to time, no? Distance is equal to velocity into time है बेटा। टाइम इज इक्वल टू क्या लिखना पड़ता है, एल अपॉन वी है, ठीक है। टाइम इज इक्वल टू एल, डिस्टेंस इज इक्वल टू वेलोसिटी इनटू टाइम, डिस्टेंस इज इक्वल टू वेलोसिटी इनटू टाइम है। सो टी इज इक्वल टू क्या लिखना पड़ता है, टी इज इक्वल टू एल अपॉन वी, नहीं तो हमारा ब्रह्मास्त्र है ना, ब्रह्मास्त्र के लिए जो हो डायरेक्ट द टाइम दैट इज इक्वल टू एल अपॉन वी वैल्यू आल्सो वी हैव कैलकुलेटेड, व्हाट इज द वी वैल्यू, वी इज इक्वल टू स्क्वायर रूट ऑफ 4g h upon 3, that is equal to 4g h upon 3 root over 4g h upon 3. So this much time it will be take to reach the bottom. Is it clear? The time taken by the body to reach the bottom would be equal to this much. Okay. Next, और एक problem देखो बेटा, under the same condition, suppose consider an inclined plane है, this is an inclined plane. Suppose consider an inclined plane, okay, an inclined plane of inclination theta दिए. Suppose consider an inclined plane of inclination of theta, and a solid sphere is initially at the top of the plane. The solid sphere is there at the top of the plane, means which is at a height of h. The inclined plane would be at a height of h. When the a solid cylinder of mass m, this is solid cylinder है बेटा, solid, this is solid cylinder, solid cylinder. It's a solid cylinder. This is a solid cylinder. It has a mass m and radius r, which is initially on the top of an inclined plane. Okay, on the top of an inclined plane. So when it is rolls downward direction, when theta has to be changed, when theta 1 is equal to 30 degrees लिया बेटा, angle of inclination 30 degrees की है, इससे velocity is equal to v1 हो गया. When theta 2 is equal to 45 degrees दिए, that means again the angle of inclination is increases. The velocity of the body is v2 at the bottom है. The velocity of the body with which reaches the bottom is equal to v2 हो गया बेटा, इसमें v2 है. Then find the ratios of v1 square upon v2 square is equal to कितने हो जाते हैं. So what is the values of the v1 square plus v2 square? Okay, I hope that you may be understood this question. This is a JEE problem है बेटा, JEE problem. See, a solid cylinder has a mass m and radius r, which is rolling down inclined plane without slipping. When the angle of inclination changes 30 degrees, it will be reach the bottom with a velocity of v1. And when the angle of inclination again increases 45 degrees, it will be reach the bottom with a velocity of v2. Then find the ratios of the squares of the velocities. v1 square upon v2 square is equal to how much? Is it clear? v1 square upon, here see, when the angle of inclination is equal to 30 degrees है बेटा, when the angle of inclination 30 degrees ऐसा दिए, 30 degrees दिए, the sphere has to be reached at the bottom v1 है, ठीक है. Again the angle of inclination will be changes 45 degrees. The solid sphere has to be reached the bottom with a velocity of v2. It is reached the bottom with a velocity of v2. Then find the ratios of v1 square upon v2 square. Okay, कैसा निकालना पड़ता है बोलो. When the solid sphere is rolls down, when it is comes to reach at the bottom, at this bottom, it has the two types of the energies. First one is rotational energy. It has the two types of the energies. First one is a rotational energy, and second one is the center of mass is moving with certain velocity. That means rotation, it has two types of energies. First one is rotational kinetic energy, and second one is a linear kinetic energy. Okay, the total energy of the object or body when it would be at the bottom is equal to the total energy of the body when it is top of the inclined plane, both will be equal. Is it clear? So that means we should have to apply what is that law of conservation of energy. What is the law of conservation of energy? Initial total energy is equal to TEI. Total initial energy is equal to total final energy, both will be equal. Okay, so what is the total initial energy? See here, when the object is on the top of an inclined plane, at that inclined plane the object has only potential energy with respect to this ground. Okay, with respect to the ground the object has only potential energy. What is the potential energy? Potential energy would be equal to what is that mgh. Mgh is equal to what is that of mv square of mvc square into 1 plus k square upon r square is already knows. नहीं तो देखो ट्रांसलेट टोटल एनर्जी इक्वल कितना हो जाता है बेटा व्हेन इट इज कम्स टू द रीच द बॉटम के ट्रांसलेशन प्लस के रोटेशन दोनों भी इक्वल हो जाता है ना. के ट्रांसलेशन प्लस के रोटेशन दैट इज कॉल्ड mgh इज इक्वल क्या हो जाता है बोलो. व्हाट इज mgh? mgh इज इक्वल टू ऑफ m vc स्क्वायर प्लस ऑफ ICM इंटू ओमेगा स्क्वायर इज ऑलरेडी नो. दैट इज mgh इज इक्वल क्या मिल जाता है बोलो. mgh इज इक्वल टू ऑफ m vc स्क्वायर plus of ICM square means what is ICM square? About this point of contact, about the ICM means what is that? ICM is equal to mk square, m k square into v, r square by omega square. No, v is equal to r omega. V is equal to r omega is already no, omega is equal to v by r, vc square upon r square को बराबर हो जाते हैं. इसे क्या लिख रहा हम बोलो, mgh is equal to ऑफ m vc स्क्वायर कॉमन करो, vc स्क्वायर कॉमन करो, 1 प्लस के स्क्वायर अपॉन आर स्क्वायर को बराबर हो जाते. ठीक है. सो दिस इज a what is that relation between height and c. But what was given, the relation was given v and theta, but in this equation we did not get theta. Now we have to convert this equation in the form of a theta. How can we have to converting c here? From this triangle it is very clear that sin theta is equal to sin theta. Sin theta is equal to h upon l है. ठीक है. h is equal क्या हो जाता है बेटा, l sin theta को बराबर हो जाता है ना. From this triangle it is very clear that sin theta is equal to opposite side upon hypotenuse. What is the length of the hypotenuse? Let's take L. That is sin theta is equal to h upon L. H is equal to L sin theta. So this value substitute here. That is mg into h value is L sin theta would be is equal to of mvc square. What was given? This is a solid cylinder was given. What is the moment of inertia of the solid cylinder? 2 by 5 mr square. 2 by 5 mr square is equal to mk square को बराबर है. This is IC. The mm gets cancel out, k square upon r square is equal to 2 by 5 को बराबर है. Is it clear? K square upon r square is equal to 2 by 5. That is this value substitute here. That is 1 plus 2 by 5 को बराबर आ गया. That is mgl sin theta. mgl sin theta would be is equal to, what is this value? 7 mvc square upon 10 आ गया. So from this vc is direct proportional to sin theta. No, from this equation it is very clear that on both sides mm will get cancelled out. vc square is equal to 10 gl sin theta upon 7 आ गए. So from this vc is direct, vc square is direct proportional to sin theta का बराबर है. vc square is direct proportional to sin theta. From this v1 square upon v2 square would be is equal to, what is that, sin theta 1 upon sin theta 2 का बराबर है. What is the sin theta 1? Theta 1 is equal to 30 degrees दिए. The velocity is the v1. When theta 2 is equal to 45 degrees, the velocity would be v2. That value substitute here. That is sin 30 upon sin 45. What is the value of sin 30? Sin 30 value is 1 by 2 upon 1 by root 2 है. इसको क्या हो जाता है बोलो, 1 by 2 into root 2, that is equal to 1 by root 2 का बराबर. Therefore v1 square upon v2 square is equal to 1 by root 2 बराबर हो जाता है. The ratios of the v1 square upon v2 square is equal to 1 by root 2. Is it clear? Is it clear or not? Respond. Okay. Next say, based on the same concept only, suppose consider a, what is that, an inclined plane. This is an inclined plane. This is an inclined plane of inclination of theta. A disc is rolling. A disc is rolling downward direction from the top of an inclined plane. This is a disc. What is this? This is a disc है बेटा. The disc is rolling like this है. The disc is rolling down inclined plane without slipping. This is a disc. The disc is rolling down inclined plane like this. Okay. when the disk is rolling down inclined plane. That is general condition. If the disk is slipping, it will be take in the first condition. What is the first condition? If the disk is slipping like this, slipping not rolling, it will be take t1 seconds slipping. When the disk is slipping on the inclined plane, it will be take t1 seconds to reach the bottom. This is the first one condition. Second one condition, when the disk is rolling, in the second one condition, when the disk is rolling like this, when the disk is rolling from an inclined plane in downward direction, it will be take t2 is equal to alpha by 2 whole power of 1 by 2 into t seconds. Okay? When the disk is rolling, when the disk is rolling on the same inclined plane, the inclined plane does not change. When the disk is rolling on the same inclined plane, it will be takes the time is equal t2 is equal to alpha upon 2 root 2 into t. Then find the value of alpha. Is it clear? Is it clear the problem? This is a disk hai beta. This is what is this called a disk. This is a disk. This is a disk. When a disk is rolling on an inclined plane in downward direction, on downward direction, first one condition, when it is slips, when the disk is slip, this is a disk. When the disk is slip, when the disk is slip, when the disk is slip, it will takes t1 seconds. When the disk is rolls, when the disk is rolls, it will takes time t2 is equal to alpha upon 2 whole power of 1 by 2 into t. Then find the value of alpha. 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 This was the question. This was a JEE mains problem only 2024. So JEE का problem है बेटा. JEE 2024 का problem बहुत आसान problem दिए इसमें. So this object was given disk है बेटा. Disk, it has a mass m and radius r. First case में देखो. In the first case, here two cases are there. In the first case, when the disk is rolls, case 1 में क्या हो जाता है बोलो? What is the case 1? When the disk is slip, not rolling, when the disk is slipping here, first case में disk slip हो रहा है. In the first case, when the disk is slipping on a inclined plane, when the disk is slipping, that means it is slipping like this, dragging like this. Slipping means which is dragging like this. It is not rolling. It is not rolling, just it is dragging on this. Okay. So what happening is there, its weight would be acting downward direction, mg, and normal reaction force will act perpendicular to the plane. This is the point of contact. This angle theta हो गया, that is mg cos theta और क्या है mg sin theta. It's a normal reaction force. So what is the driving force? The driving force is given by the driving force. What a driving force? F is equal to mg sin theta. The driving force of the object is given by F is equal to mg sin theta. That is ma is equal to क्या हो जाता है बोलो? mg sin theta को बराबर हो जाता है. On both sides mm will get cancel out. That is a is equal क्या है बेटा? A is equal to g sin theta. When it is slip, with what acceleration it would be reach the bottom? A is equal to sin theta. With this acceleration, the object would be reach the bottom. So with this acceleration, it would be reach the bottom. Then how much time it will be takes? So let's take t1. Already we have taken t1. The length of the plane would be LO. Length of the inclined plane would be is equal to LO. Therefore, what is the time taken? T1 is equal to square root of 2L upon A is already knows. Okay. That is T1 is equal to root over 2L upon what is the A value? G sin theta. When the disk is slipping on an inclined plane, it will be takes the time T1 is equal to root over 2L upon G sin theta. Let's take this the equation number 1. Next case 2, in the second case. Case 2 में क्या हो गया? The disk is rolling. When the disk is rolling, it will takes the time T2 is equal to alpha by 2 whole power of 1 by 2 into T. Is it clear? When the disk is rolling, when it is rolling, what happening is there? When it is rolling in the case 2 में same angle है बेटा. When it is rolling, what happening is that the center of mass is moving. A is equal to G sin theta upon 1 plus K square upon R square is already knows. Okay. When it is rolling, the center of mass will move with an acceleration of A is equal to G sin theta upon 1 plus K square upon R square. But the given object was given disk है बेटा. For disk I is equal क्या हो जाता है? mr square by 2 is equal to mk square. Gets cancelled out from this. K square upon R square is equal to 1 by 2. Is it clear? Therefore, this value substitute in the above equation, then you will get the acceleration is equal to G sin theta upon 1 plus 1 by 2 हो जाता है. इसमें क्या हो जाता है बोलो? 2G sin theta upon 3. So with this acceleration, the center of mass will be reach the bottom. In the second case, this is second case. So how much amount of the time it will be takes? In this case, the time taken by the disk is given by T2 is equal to root over 2L upon A beta, that is equal to root over 2L upon what is the value of A? 2G sin theta upon 3 है ना, 2G sin theta upon 3 है. So T2 is equal to what is the value of T2? T2 is equal to this is what I am writing, see here, root over 2L upon G sin theta is a 1 term into 2L upon G sin theta हो गए 3 upon 2 आ गए. Next second term is the T upon 2. 2L upon G sin theta value is nothing but T1, no? That is the T1. It was taken time T1 is equal to T given, that is equal to T2 is equal to T into root over 3 upon 2. So this is compared with T2 is equal to alpha by 2 into 1 by 2 into T है बेटा, that is equal to T into root over alpha upon 2 से compare करो. So what is the value of alpha here from these two equations? So from these two equations, it is very clear that the value of alpha is equal to 3. The value of alpha is 3. Is it clear? Is it clear or not? The value of alpha would be is nothing but 3. Okay, this is the 2024 problem है, बहुत आसान प्रॉब्लम है. ठीक है, आई होप दैट यू मे बी अंडरस्टूड. वो परेशान होना जरूरत भी नहीं है, डायरेक्ट कॉन्सेप्ट सीखना पड़ता है. कॉन्सेप्ट फार्मूलास में वो क्वेश्चन पूछ रहे हैं, थोड़ा लॉजिकल के सोचना पड़ता है. ठीक है, इज इट क्लियर? ओके, नेक्स्ट मूव द next one more problem. See, based on the concept of inclined plane only. Suppose consider an inclined plane here. This is an inclined plane. Okay, and inclination theta, an inclined plane of inclination theta. Similar inclined planes ले हो. Suppose consider an inclined plane of inclination theta. This is the theta. Okay, an inclined plane of inclination theta है बेटा. So y-axis है, this is a x-axis. Okay, a solid sphere having the mass m and radius r which is rolls down from an inclined plane without slipping. This is a solid sphere. S means solid sphere. A solid sphere is a rolls down without slipping from an inclined plane. Then this is a solid sphere hai beta. Is slipping, rolling without slipping. Solid sphere is rolling without slipping. So it will be takes a time of t1 when it would be reach the bottom. It will be takes the time. How much time it will be takes? T1. Okay, it will be takes t1. It will be takes t1 seconds. It will be takes t1 seconds to reach the bottom. Next, this is the same inclined plane only. Inclined plane does not change. The inclined plane would be same only. The inclined plane does not change. On the inclined plane, this is a solid sphere hai beta. Next, another sphere is a halo sphere. This is a halo sphere. On the same inclined plane, this is the same inclined plane. Inclined plane does not change. First one I did placed a solid sphere. It has a mass m and radius r hai. Second one is what is the second one? Second one is a halo sphere taken. I have taken halo sphere. This is a halo sphere having the same mass and same radius. Mass and radius does not change. They would be remains constant only. Okay. So it is also rolling in downward direction without slipping. When it would be reach the bottom, it has taken time is t2. It has taken time t2. Okay. So what is the relation between t1 and t2? So this was a question. It is a very important question. Beta. This is a JEE problem here. What's the problem here? JEE problem. JEE problem. See, a solid sphere having the mass m and radius r is